we were discussing on what? The operators in C programming. Okay, in the operators in the C programming, broadly we can categorize it into 3 types. This is the broad classification based upon the number of operands. Based on number of operands, right? So first type is what? Called as unary operators. Second one is binary operators, and third is ternary operators, right? So how this classification is done? Based upon the number of operands it required, right? Unary means what? Only one operator. Binary means 2 operands. Then ternary means 3 operands, right? So in that one, then we have started with the different types of operators, okay, based upon what type of operation they perform, right? So first we had covered the one type of the operators, which is very simple. We call it as arithmetic operators, right? Arithmetic operators perform the different arithmetic operations such as addition. For addition, we use the plus operator. Then second one is a subtraction, that is negative minus sign, and then multiplication. For the multiplication, the operator is star, and then for division, the sign is the forward slash, and then the modulus operator is the percentage symbol, right? So arithmetic operators falls into the category of binary operators because it requires 2 operands, right? Now, later we have started with the second type of operators, that is called as relational operators. What relational operators try to find out? Basically, what they do, they compare, right? Can we say the arithmetic operators compare 2 values? Okay, 2 values in the sense it's 2 operands. The first operand will be compared with the second operand. So the operators over here is that the less than, greater than, less than or equals to, greater than or equals to, then not equals to, and equals to. Okay, these are the 6 different operators which are of the relational operator. So in that first one we were discussing, right? So we have, I think we have discussed few of them. Let us quickly recall all those operators. This is less than. Okay, less than means what? Suppose if there are 2 operands, say 20 less than 30. We know what is the output or what is the result of this particular operation. Always the relational operators gives the result in the form of what? Yes or no. In other term, we can call it to be what? True or false. Or in other term, we can call it to be the binary values, the numbers 1 or 0. If you notice here, yes, true and 1 are all synonyms. They indicate the same type of results. In the same way, no, false and 0 indicates the same set of values. Okay, now considering this example, less than 20 less than 30, what will be the result here? It is going to be true. True. It is going to be true, or in other terms, it is 1, right? Then 40 less than 20. What will be the result here?
False.
False.
False. A 0 value.
False.
Right? Then the next one is the greater than symbol. So greater than symbol is what it indicates? It indicates the greater than 2 numbers. Say first number 2 greater than 4. What is the result here?
False.
False, right? 2 greater than 4 is a false. So the result is false over here. Or else in the other numbers it is 0. So take the other example. Say 30 greater than 20. The result is true.
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 Yes. Okay. Then the next set of operator is less than or equals to. Okay. So let's go through this one. We call this as what? Less than or equals to. Less than or equals to. Take the example. Say 3 less than or equals to 3. So what do you think here? What will be the result? 3 less than or equals to. Yes, 3 is less. Either the first operand can be less than the second operand, or it can be even equals to the second operand. So you may notice here 2 different symbols are used. One is the less than symbol, other is the equal to symbol. So that constitutes it to be less than or equal to. Then the result will be what? is going to be true. Result is true.
True.
If we have something like 4 less than or equal to 3, 4 less than or equal to 3, then what will be the result here?
False.
It is false. Correct? Why it is false? 4 is, it is not equal to 3 also, and also it is not less than 3 also. So it is false. So that what we call a relational operator, one of the less than or equals to. Okay, then the other one, the next one is what? Is called as greater than or equals to. Greater than or equals to. So again the name indicates greater than or equals to. One greater than symbol and second followed by the equals to symbol, right? Say what it will do, it will try to compare the first operand whether it is greater than or equals to the second operand. Say for example in here, if you take 4 greater than or equals to 4. So what do you think, what will be the output now? 4
True.
greater than or equal to 4. Yes, it is
True.
True,
True.
sir.
True.
it is true. Then say the other example, 10 greater than or equal to 5.
False.
True.
Look at again, 10 greater than or equal to, yes,
False.
False. True.
now
True, sir.
it is
True,
true.
sir. True.
It is true.
True.
Look it
True, sir.
again. It
True,
is
sir.
10 greater than or equal to 5. Yes, 10 is greater than 5. It is not equal to 5. But at the same time, if you look, the other operation is what? Greater than. Right? So
Greater
that
than.
is true.
True.
Okay. Then other example, say 3 greater than or equals to 10.
False.
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 It is
False.
obviously false.
False.
0, sir. 0, sir.
Sorry, it is 0, right? I mistyped it as a 0. 1. Okay. Following it? Okay. Then next comes the two very important operators. Pay attention here. This, what we call it to be not equal to. How it is pronounced as not equal to. Okay. Now let me explain it more here. Now first I will write let me take one number. 4 not equals to 5. Now how to read it, first try to understand here. 4 not equals to 5. Right? See,
True.
here we have what? Two operands.
sir.
Okay. Here we have first. Okay. Later you can answer. I will ask you to answer. During that time you can answer. Okay. Now, 4 is what? First operand. Same way, 5 is what? Second operand. What relation it is trying to find out? It is trying to find out the relation between first operand with the second operand. So what is the relation here? If you notice, two symbols are there. First one, exclamatory mark. This is something new which you are seeing here, exclamatory mark, and then followed by equals to. So exclamatory mark in the programming concepts indicates something called as a not. It is not like that. Okay, some negation, we can say the negation, right? So not equals to. So how we need to read this particular words, letters? 4 not equals to 5. 4 not equals to 5. Now what shall we say here? Is this particular statement what I made, is it a true or a false? No. 4 not equals to 5. Yes, 4 is not equals to 5. That means result is what? Result is true. Okay, now in the same way, let us check this one. 5 not equals to 5. Now, what will be the value now? Result here. If you read the statement, 5 not equals to 5.
False.
False.
Statement is
False.
it is false. 5 not equal to 5, I am telling. That means 5 is equal to 5. That means my condition, my statement, what I am making is a wrong statement. So it is the result is false. Okay, understood this one? The not equals to operator. This is very tricky to understand. You need to just pay little attention to the what variables or the what numbers we are using, and then we can say the outcome result, whether it is a true or a false. Okay, now next. The last operator, relational operator, is called as is equals to. Notice here, pay attention here. This is very, very important. What I have written here, two equals to symbols. First one, second one. Two equals to symbols if I use, then it is considered as the relational operator by the name is equals to. So what actually this is equals to will do? Now again it will try to compare the two values. Now for example, 4 is equals to 4. Now how to read this one? Pay attention here. 4 then is equals to. Why I can say is equals to here? Because there are two equals to symbols. Okay, then 4. That means 4 is equals to 4. Result either can have a true or a false. So what do you expect here? The result, as it a true or a false? What
True.
is 4
True.
4?
True, sir.
4 equals to 4. Yes,
True.
it is true. It is true. 4 equals to 4 is true. Then the same time if you write something like 4 equals to 5.
False.
False.
False. 4 is equals to 5. No, 4 is not equals to 5. That means it is false.
False.
Understood?
0.
The relational operators? If it is understood, let us work out certain examples here. Okay. This time, pay attention here. What I'm going to do here. Say, let us say there is one variable, integer variable a, whose value is say 20, and there is another integer b, variable b, and whose value is say 25. A is 20 and B is 25. Now tell me the answers here. First one, A less than B. What is the result?
True.
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 It is true.
True.
So shall I write it to be 1 or 0 in this case? If it is a true,
1.
1.
1.
If
One.
it will be 0.
1.
It is 1. Then next one. A greater than B. So what is
False. Zero.
0.
0.
Zero.
0.
0? 0. Right? Then next. A less than or equals to B
1.
1.
is 1. Next, A greater than or equals to B
0.
0.
Zero.
0.
0. Then A equals to B
0.
0.
0.
0.
A not equals to B
1.
One.
1. Right? A not equals to B. Yes, 20 is not equals to B 25. So that is 1. Very good. Okay, that is about the second type of operators that we call it to be a relational operators. Okay, then shall we try out this simple program, just a simple program, and try to see whether we get these 1 0 1 0 or whatever those values. Okay, let us see this one. Okay, let me open the terminal and show you. Arithmetic operators already we have seen. Okay, now this time let us check out the relational operators. Okay. It is opening up. Just let us wait for seconds. I will take a new file. We'll take a new file here, and first step is that I will save this file in order to the color contrast, right? So hash include stdio.h. Okay, let me save the program first, and let me give the name this as we are trying to look for relational operators, right? So relational operators demo dot c. How I have written relational. After that relational, there is one special symbol, right? A dash. It is not a dash, it is underscore. Okay. Relational operator demo. And then I will save the file. Then void main. And I will write the necessary statements over here. First thing is that I require two variables, say integer a, integer a comma b. Okay, then let us put the values. A equals to 20 and b equals to 30. Okay, two values. Okay, now I want to print the values here, right? The based upon the relation what we get. Now I know that whenever this a less than b, okay, it is going to give me values in terms of numbers as what? 1 and a 0, right? Understand here. A less than b, what it will give? Either it will give the corresponding values in which particular format? In the format of 1 or 0. If it is true, it will give 1. If it is false, it will give 0. That means what? This 1 and 0 are what? These are integer numbers, right? These are integer numbers. Okay. Now you see here how I construct the printf statement. Printf. Okay. This is printf. Within the double quote, what I will write now? Okay. A less than b. Okay, first let me print the values of a and b. Say a equals to percentage d. Okay, then b equals to percentage d. Double quote complete. Then I want to print the a value. I will type it to be a, and then b value I will type it to b. So what this will do, it will just print the values of a and b. Let us check it out first. Okay, let us check the output. I have done what? Simply I have written a one program where I will print two numbers, right? Say C program, okay. GCC space, program name is what? Relational operators demo dot C. Compile. If there are any errors, it will display. Since there are no errors, it has not displayed any messages. Execute. It is simply printing what? A equal to 20, B equal to 30, right? Okay. Let us add a slash n also at the end. Now, next statement is what? Say print f. A less than B. A less than B is equals to. Okay. Comma. What I will write here? A less than B. Pay attention here, student. A less than B. So what is this A less than B? It is going to give me a result, right? What result? Based upon the comparison what it performs, either it will give a 1 or a 0. If the comparison is true, then it will give 1. If the comparison is false, then it will give 0, right? So in this case, both 1 and 0 are what type of numbers? Those are integer numbers. So since it is an integer number, I will write the format specifier as %d followed by /n. Percentage d, why I wrote percentage d here? Because the value what I get here, okay, a less than b, it is either 1 or a 0. So 1 and 0 are what here? I can take it to be a integer numbers. So for the integer numbers, the format specifier is what? Percentage d. Now suppose if I compile this program and then execute, what I should expect? I should expect it to be a less than b equals to whatever this result provides, right? Let us compile the program and check it. Compile the program. Okay, there are no errors. Then execute. Okay. Now you see here a less than b equals to 1. From where I got this particular value 1? That I got it from the result of this particular operation. Okay, what is the operation here? Relational operation. A less than b. So what is the value of a here? A value is 20, right? Then operator is less than. Second operand is what? 30. So I know that 20 less than 30 is what? It is true. True means what? It gives the value 1. So this 1 will get substituted at this place and that 1 will be printed because we have taken the percentage d over here. In the same line, if I write here, print f a greater than b equal to percentage d, then a slash and double quote complete. Here, if I write a greater than b, okay, then can you tell me what will be the output over here? What it will display?
0.
0.
It will display a greater than b equals to 0. Let us compile the program and check it out. See, a greater than or a greater than b equals to 0, right? So this is how we are trying to experiment our theoretical concepts here. Okay, so what I will do, I will just copy this particular line and then I will print it, just paste it on the other lines for all the 6 different operations. So here next one is what? Less than or equals to, here greater than or equal to, here not equals to, and here equals to. Okay, same way I will change the operation here. So it will be less than or equals to, then this is greater than or equals to, this is not equals to, and this one is equals to. Notice here, whenever I'm typing equals to symbol, two double equals to symbols I have to choose. Okay, then now tell me what we can expect here. I can expect to be 0. What about here? I expect the result to be what? 1 or 0?
1.
1. What about in the next line? A greater
0.
than
0.
0.
then A not
1.
1.
1. A equals to
0.
0.
0.
0.
so a sequence of 1 0 1 0 1 0 I should get as the output. Compile the program and then run the program. See, we got the correct answers. A less than B, yes, it is true, that is 1. A greater than B, yes, this is false, answer is 0. A less than or equals to B, 1. A greater than or equal to B, 0. A not equals to B, yes, it is not equals to B, so answer is 1. And the last one, 20 equals to 30, no, it is false. Right? So is that understood, student? Relational operations?
Yes, sir.
Okay, I hope you are making the rough notes in a rough page, because on any particular day I will be conducting a simple quizzes kind of assessments. Okay, you might have already experienced one type of a quiz, right, where I had shared you some link and you have gone through that particular quiz. In the same way, I would be initiating some quizzes, live quizzes. Those will be live quizzes. Means whenever the class is there, during that time you will get the questions, and immediately that particular link will be disabled as you enter the result. So only once you will be able to answer to those quizzes. Okay, so you need to be very attentive in the classes. Whatever the concepts I teach, make a simple notes, a rough notes in your notebooks. Okay, rough books, and then have it with you whenever there is a quiz is being conducted. Okay, now one more point, student. Since today, I think you do not have a computer fundamental class, right?
Yes, sir.
Yes, sir.
So what I will be doing, instead of computer fundamental class, I will be engaging another extra class for C programming. I hope that will be okay for you, right?
Sir, soon after this class?
That the timing I will let you know, because soon after this one I have another class for another semester. For 5th semesters I have another class. So after that particular class, I will probably your class will be there. Let me see the timetable once again. It's here. So you have first CF was there, CF was not taken, then 11 o'clock C programming I'm taking, and at after my program you have English class, right? So 12 to 1 is English class, and I can have the class after 1 o'clock then. I will just communicate you in the WhatsApp group the timing about the second class today. Okay, probably it will be at 1 o'clock. I will just ask the corresponding faculty of English when it is going to complete. Then I will do the thing. Now I have another class. After this, I have a 5th semester class. Okay, and then we'll see. Okay, one more class is there. Just keep it in mind. Fine. So the operator, the second type of operators is understood. Let us go to the next type of operators. Very important. Okay, logical operators. Logical operators. So basically, what are these logical operators? Anybody has come across with the logical operations in mathematics in your previous studies in +1 or a +2? I don't think so. Have you? Logical operations in mathematics or something called as a, have you heard about something called as a truth tables? Probably.
Yes, sir.
Yes, sir.
Yes, sir.
Is it? When did you study
Yes, sir.
students? Where did you basically study this one? In maths?
Sir, in
Physics.
maths,
Physics.
in
Physics,
physics.
sir.
Physics.
In
In
physics.
physics.
Yeah, yeah. In PUC 2 you have in physics, right? Okay.
Yes.
Logic
No
gate.
worries. Those who have
Logic
studied,
gates.
yeah, those who have studied the PUC in as a science, they might have know what these logical operators. But those who are from the commerce background, don't panic. This is very simple. Logical operators are very simple. If you know the fundamentals and basics, that would be very easy to learn the logical operators. Okay. Now, logical operators. Let me give you some brief the background about this one. Okay. Now, logical operators, in order to understand logical operators, first we should know relational operators. So that means already we have studied the relational operators. That means it's easy to learn logical operators. Now, to just give another, when say, when we are discussing the relational operators, okay, it was what? It was a binary operators. Binary means it requires two operands. Say operand 1. When I write OP1, that means it is the first operand. Okay, and when I write OP2, that means it is second operand. So for an example, operand means what? In the earlier case we had taken 10 less than 20, right? So in this one, operand 1 is what? It is 10. At the same time, operand 2 is what? 20. Okay, now if you look into the data type over here, or the what type of value are the operands, or it can be of what? It can be of integer, or it can be of say sometime the floating point number also, or sometime it can be of a character also. When I say character, say I can say A is equals to A, right? I can compare two characters. A is one character and second operand is again A. I can say A is equals to A. That means the true is a true. At the same time, if I write something like this, A not equals to C. So what will be the result? Yes, definitely A is not equals to C. Both are two different one. That is true over here. Okay. Now there is something called as one more. If I can put over here, small letter A equals to capital letter A. Have you studied something called as a ASCII in your computer fundamentals?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Very good. That means you know something called as an ASCII. Can anybody tell me the full form of ASCII?
American Standard Code for Information Interchange.
American Standard Code for Information Interchange. Yes. Very simple, right? Just to remember what these are nothing but certain type of the numbers, integer numbers given to each of the characters on the keyboard, basically, right? Like that you have a different type of characters. A is treated as its own ASCII value, right? Do you know what is the ASCII value of A and capital A? Okay, before that, let me ask
Yes,
you,
sir.
is small a, is it equals to capital A?
No, sir.
No, sir.
No, sir.
No, right? Because these are two different cases. One is written in the lower case, whereas other one is written in the upper case.
Uppercase.
Both of these are having two different ASCII values. What is the ASCII value of A, students?
Capital A 41, sir.
Okay,
41,
capital
sir.
A is what?
41.
41. Okay. What about lowercase a?
61.
51.
61.
61. Oh. So both the answers are wrong. Both the answers are wrong. A is not 61, lowercase a is not 61, capital A is not 41. Okay, do one thing then. I will give you it as a homework. Okay, homework in the sense in the next class. Okay, 1 o'clock class. You just prepare get the notes of this one. What is the lowercase a ASCII value? What is the uppercase? Okay, all the ASCII values you have it to yourself. I will ask questions during that time. Take it as a assignment. We will discuss that later. Now here the point to notice what we are discussing here is that whenever or arithmetic operators are there, the operands, the first and second operand are what? The numbers, or sometimes it can be characters or floating point numbers. But when we discuss something called as a logical operators, okay, then these operands, okay, they are not as simple as the integers. They are not the floats. They are not even the characters. Means what? In order to operate upon these logical operators, the operands we require, those operands are basically, these are not the integer values or the float values or the character values. They are something different. Okay, we call them to be the true or a false values. They operate upon true or a false values. Again, these logical operators are what? They are again binary operators. Binary operators. Binary means what? It requires two operands, operand 1 and then operand 2. Okay, now logical means the inputs for these logical operators will be either true or false, right? The input for this binary operators means the operands for this binary operators are always what? The values in terms of true or a false. That means what? Either it will be 1 or 0. Either it will be 1 or 0. So here we will consider it to be a true or a false for the moment. True or false. When we have set of values, then there can be a 4 different possibilities we can have, right? In maths you might have studied. So 4 possibilities means what? Both the operands, say this is operand 1, this is operand 2. First time, say both the operands can be false. Okay? Both the operands can be false. Second possibility is what? First operand may be false, second operand may be true. That is also possible. In the third instance, the first operand may be true, second operand may be false, and the last possibility is what? First operand can be true and the second operand can be true. These are the 4 different types of possibilities we can have when we have 2 different values, right? When we have a true or a false, then these are the possibilities. If you just look at here, operand 1, FF, TT, that is false, false, true, true. Then the next time it is FT, false, true, false, true. Are all these 4 different set of values or the same set of values? Please answer to this question. Are above set of values are same or different? Are they same or different?
They are different.
3 are
Different.
different. Or all 4 are different?
Four are different.
All
2
4
are
are
different.
different. If you see first one, both
Different.
are false. Second one, first is false, second one is true. Then you have true, false, then you have true and true. Right? So these binary operators always work up, these logical operators always work upon the operands which are in terms of true or a false.